It's 4:30 and let's start with today's talk. Here today, as always, Alex and myself having this webinar series, talking mainly or focusing on security in the cloud native ecosystem, providing different perspectives, also not only with security, but also with respect to how you develop in cloud native in general. Today's topic is securing the layer below Kubernetes Part II, which is as an additional information to the one that we have last time in the last presentation. So it's automated hardening for Linux. The content will be, as always, we do very short recap about what we did the last time and what we talked about. And it was about polymorphing for Linux. And today, when we say automating the hardening of Linux operating systems, we are going to talk about OpenSCAP, which allows the automation and the secure configuration of Linux operating systems. So last time we got to know polymorphing for Linux and Polyverse as a tool of it. We discussed the general advantages of Polyverse with respect to different control mechanisms or security control mechanisms, such as stack canary or address layout, randomization, etc., or shadow stack, and that all these mechanisms so far have, of course, their advantages, but they have also their weaknesses, and they have been workarounds out there for bypassing these measures. So Polyverse is actually, it provides a kind of groundbreaking technology with polymorphing the packages on the operating system level. Mainly it works, of course, in also in other systems where the code is open, where you have the source and you can recompile that source, create a different version of that code in a machine code, and you can then run it, and which is the scramble process, and then you can install and go on. So it doesn't interfere with your general working process. So it doesn't create you any operability or compatibility issues. And the general idea behind that is that it detects attacks, even it prevents zero-day attacks, because your instance, your operating system instance, is becoming unique. Meaning that if an attack is known out there, or if a vulnerability has been exposed, and there is no workaround for that, this attack wouldn't scale if you imagine having a different unique instance of the operating system. So this is actually the main idea behind that. And if you are more interested, please listen to our previous talk, and we have provided also some information where you can have some more reads about it. Today we will talk about the OpenSCAP in general. So what is OpenSCAP actually? Well, OpenSCAP is an open source project which implements the security content automated protocol, which is a protocol developed by the NIST, the National Institute of Standards and Technology, for automating the configuration, the hardening of operating systems. So OpenStack is the open source version of it. It provides actually, and it's called Open Security Content Automation Protocol in here. So the project you can find under https://openscap.org. And it provides tools for implementing and enforcing the SCAP, let's say the protocol, or enforcing or running the protocol, executing the protocol, and enforcing the configurations, which you can implement as XML files. And we'll talk about it later, and we will see it in the demonstration. OpenSCAP itself, it's available for various Linux distribution and newly for Windows. The version that we will see is the 1.2. It implements the 1.2, so it doesn't support Windows so far. So if you implement, or if you use, the version 1.3, you would be able even to use it for Windows. This means that you can use it to configure and to harden the system. So you can configure and harden different distribution of Linux, and you can also harden now Windows systems, but you can install the one of the tools that it helps you to do this in mostly all environments, including also Mac. What are the features? So the main features that it does, it provides security compliance. So imagine you want to audit your system and you want to get certified for a special whatever services, let's say PCI DSS. So in case you are processing payment data and on your website, and you are running, or you are hosting your website somewhere, but you are in charge of the operating system. So you have built up the whole system. Imagine you are using vanilla stack, and below vanilla stack, of course, you need the kind of nodes running some operating system, but they need to achieve or to comply with this standard. So OpenSCAP would give you this opportunity to achieve that security compliance in an automated way. And not only that, but even more. So we will get to know this when we see the tools and from the tool set that it provides. Another thing is the vulnerability assessment. So also it provides the possibility to have an assessment of well-known vulnerabilities that might be in your systems or in the libraries and the packages that your system has included. So it will at least warn you that these libraries or whatever packages that you have in your system might suffer some vulnerabilities. But of course, this is just a state, a current state. Yeah. So it can only identify those vulnerabilities that are well known for now. So meaning that if you are keeping your system up to date and you are running this vulnerability assessment once and trying to mitigate those vulnerabilities that make sense to be mitigated in your context. So this would then be, let's say, a process that it would not repeat as much as for in general. So you would keep the vulnerability assessment. You need to update the CVE, but OpenSCAP does this for you. So this is the idea behind that. Okay, so why is this happening? Sorry for that. Let's do some reload. Okay, now it's working. I don't know why is this happening. Maybe some internet connection. So let's start in here with the tool set. So
just do a Control R or something.
So it doesn't want to load.
Which slide was that again? The third one?
6. I am on slide 6. Okay. So let me open this another time.
F5.
Yeah, so what I'm doing here. F5.
You at the top slide, or it should be the slide one, and then you go. No, where was it? Yeah, you have the % button in the right. Yeah.
Yeah. Yeah, my system is a bit slow today. I don't know what's going on. So no, these are notes. What here is this?
Just click on %.
Yeah, I did. Okay, so let's go full screen. Okay, so let me try. Yeah, now it's working. Okay, sorry for that. Seems there was something wrong with that. So let's start with the first tool that we have in OpenSCAP, which is the base, right? So it's the OpenSCAP base. This contains actually is a command line tool that it contains, and it can be used to parse and evaluate the components, meaning whatever system you are trying to evaluate, be this an operating system or a different, let's say, a browser, web browser, etc. So we will have later a look on what kind of different system actually OpenSCAP can be used to evaluate their configuration and also their vulnerability state. So this is the basic actually of it. And then you have the OpenSCAP daemon, which is a daemon that it continuously evaluates your infrastructure for, as we said, the compliance and the vulnerabilities. It enables you to, so this runs in the background, and it makes sure that the machines and the containers running are evaluated according to some schedule that you can specify. So imagine you would use the OpenSCAP base in a kind of one-time or manual approach. But imagine your infrastructure contains more machines and they are running all the time or 24/7. And so you would like to have something automated in there. So there is a tool you could use for it. So go for the OpenSCAP daemon, install it and use this, which the base or the core behind it is the OpenSCAP base. The OpenSCAP workbench, it provides, of course, a kind of graphical tool, yeah, which brings OpenSCAP more or less also to the average user, meaning that you can use this graphical user interface, which we'll show in the demonstration later for performing evaluations according or towards your systems. And the nice thing about it is that it also enables you, as we will see, to customize your security configuration, right? So in order to do some security assessment, you would need a kind of base configuration that you are comparing against. And usually those are provided by the OpenSCAP security guide. So there you find the configuration, like the base, the templates that you need to follow. But let's assume that these are not enough for you, or let's assume that you are running an operating system for which there is no PCI DSS template there. So you need to create this by yourself. And there is where the OpenSCAP workbench can help you do that, because it provides you a graphical interface, so you do not need to look into the XML files, which are pretty huge. You can imagine by the number of configuration that you would have in an operating system. So assuming that is why it makes sense to use this tool for even doing the customization according to your needs. Another one is the SCAP, OpenSCAP Timony or Timony or whatever, as you want to read it. This is, it provides you the possibility to store your results. So this provides you, after you run a scan, you can store these results. So it's a kind of, well, it's a database in that sense in the backend. And you can store your results in there, and anytime you run, let's say anytime, for example, you're using the OpenSCAP daemon, it runs, it checks the systems, it gets the results back and stores them in a database, so you can create statistics about that, about the attacks, for example, that might have been possible in your infrastructure, looking at the vulnerabilities that you would have, or even looking at how, or if things have changed. Let's say you are configuring some system in a certain way, and because of whatever, some maintenance task, someone has changed the configuration, but has not done this, let's say, automatically back. So this is where you might identify such things, right? So if you haven't, let's say, push, or if you don't want to enforce the configuration automatically, because, well, as you can imagine, the configuring the things automatically, it can, well, come into a situation where the system is not working, is not operating as it should operate, because you are using too strict configurations, or something is missing in the permissions. So the system is not operable anymore. So it might make sense that you don't want to enforce them. And there is where it makes sense also to have this, what happened, or why this happened. So you can get some idea about that. The next tool that you have in this set is the so-called OpenSCAP Anaconda add-on. So this, it has the advantage. So of course, this enables you to secure or configure your system securely during the installation. So meaning, what we have talked so far is that the process is, you install something, be this operating system or whatever application, and after you install that, you would run OpenSCAP against it. You would see what configurations you need to change. You would then decide, okay, this I want to change, or you can even do this automatically, what you want to change, and then you're good to go. So then your system, at least for that current state, for that moment, is compliant to that standard that you used. With the Anaconda add-on, you can do this during the installation. And of course, this is now meant for systems which are very security critical, and maybe also in real time, security is critical. So, but there is the possibility to even do that. So I was talking before about the OpenSCAP security guide, and it provides you security policy, which is written in form of the SCAP documents, meaning the XML files with the configuration where you have the common platform enumerations, and where you have the possibility to configure your system. And this is available, as I said, for different operating systems, but also for different applications or middleware. As you can see, like, for example, we have operating system, the Red Hat family. You have Oracle for Debian, but you have also applications like Mozilla Firefox, and also the Java runtime environment, and so on. So you can use this for these, all of this application. You can automate the security configuration of them. I just took a screenshot, so you can, these are screenshots that I took from the project web page, of course. And you can see here, for example, if you, as of course, OpenSCAP, I should have mentioned this maybe from the beginning. So good that I'm thinking about it now. It's, of course, a Red Hat supported project. So, and where you can see that it's there where you see that for Red Hat, you have a lot of standards that are out there as templates. So imagine you use Red Hat Enterprise Linux 8, you would have already different templates that you can just use and make your system compliance towards the standards. While for other systems, for example, Fedora, which is of course also Red Hat based, but it's not the enterprise solution. So the community needs to, let's say, contribute into that, meaning that the community needs to create those standards while they're using them. This is something that, we at Cloudical are aiming to do, contributing back to the community. So using these open source tools in general. And also this is the spirit behind Vanilla Stack in general, that we'd like to contribute back to the community open source. And this is something that we would like also to support in general, that people that are doing or creating those standards, they should put them into the open source project so that they are available also for other people, also for non-security people or skilled people, that they can just use them and make sure that their system have a certain level of security or are compliant to certain standards. So the basic homework, let's say. So now we are in the demo and would like to have some view for the OpenSCAP bench workbench. So let me log in. I always get kicked out. So
it is great to see such a set of tools available.
Yeah, it's provides you a lot of help. So you don't need, let's say, well, because configuring all the whole operating system and thinking about all this configuration items, well, it's not that easy, right? So you would really need to know that distribution very well. So it's a very, very helpful tool set. And it makes sense to use it as especially like with a workbench, where you have let's say, very usable tool. It's not very complicated. We will just see it. It's a couple of clicks you need to do in general.
Yeah, but we have the web interface available, don't we? So
yes.
We don't need to log into the system.
Okay, so got it. So here, as you see, when you install the OpenSCAP base and the security guide, so you need to install the security guide for being able to evaluate systems. Under the following path, under user share, XML SCAP, SSG, and content, you'd find all of these standards and templates that have been implemented, that they come with a security guide. So there are a lot of them. So and you can see, so you have different ones that you can use. You can use what makes sense is to use those with ending DS, which means data stream, because they would integrate both as well the the XML file, the extensible configuration checklist, and description format, meaning the one that actually looks into the configuration of the items of the operating system, and also the OVAL, meaning the Open Vulnerability Assessment Language. So this is combined. And combining also the the enumeration, the configuration platform enumeration. So this is the way you should do it. And before we get into time pressure. So let me start it. So if, as you see, so this is what it do, and what the system does, it already somehow recognize the system or the default operating system that you are running. Of course, there is, well, you can do some reconfiguration of the system that doesn't do this, but well, why you shouldn't do this at all? So let's assume we want to do Fedora, which is the system, the operating, the workbench is running. I would go into, say, load content. And as you see, you can choose here between running this on the evaluation on the local machine or on a remote machine. You have, as you would see, 3 different standards that you can run and evaluate the system against. And they have, of course, different number of configurations that are available that you can use. So for example, if you want to do the protection profile for general purpose operating system, you need to reconfigure, let's say, 208 items. If you want to run your Fedora PCS DSS compliant, you use that standard, or just a standard system security profile for Fedora, where you have less, let's say, less items. What I was saying before, you can also customize this. Let's say we want to customize the PCI DSS. So you say, well, I have some more requirements to do the for doing the PCI DSS. So I can customize this, and this would help you create. So you can go then through this list, and let's say whatever configuration you need to do in here, you can go, and it's just a matter of click, right? So if you go in here, it provides you an example how you do this, a description, what it needs to be done, and then you can just click this, and the tool, it will check this if that has been configured as it should be configured. And it provides you with information how you should actually do, or how you can reconfigure this. Also, it can do this automatically for sure. What you can do also is, when I was talking about the remote machine, but of course, what is important here, the OpenSCAP base needs to run on that remote machine, so that it's able to compile and to parse and to interpret the file. So let me start this for the remote, because you need to do that. So let's say we have so I have a CentOS machine, and I load the content, and I say remote. So let and I'd like to scan. So I can also run, do a dry run, or what is also interesting in here, you can create bash scripts or Ansible or Puppet or Ansible playbooks that you can then run against your system for configuring it in also in an automatic way. If you don't want to the tool.
Yolland?
Yes.
Are you sure that it should be 190 for the host? Or shouldn't it be 192? Oh
yeah, you're right. Sorry. It's a good one. So 192. Yeah, so this is what you can do. And let's say if you want to scan it, let's say it will of course ask me for the password of the system, and then it will run, it will process that on the remote machine. And it will already check that some of the things are failing in the remote machine, and some of the things are passing. And then you can decide what needs actually to be secured and what is not necessary in the context you are running. What also I wanted to say about this creating the Ansible script. So I run this before locally, and you can see here, so it creates an Ansible playbook that you can just run against, well, you can use into the deployment, when you deploy machines with Ansible, you can use this playbook for configuring the machines from the beginning, maybe from the installation, as we were saying before, by using the Anaconda. So you can even use this for as a intermediate step, meaning that you run it, that you see that you do some testing at least with your environment, so that you see that this is not more or less creating operational issues, and then you can use this Ansible script after testing that for creating your machines in an automated way. So we are at 5, so we are actually also done here with a demo. This is the most I wanted to say about it and show. So this is actually what you can do with the tool set. And if there are questions about it, I'd be happy to answer them in that respect. So.
Yeah, it's an interesting to see this tool.
So this is still running, and
okay.
Well,
I don't think we have any questions.
There are no questions so far as I can see. So we get call it for the day, and thank everyone for their attention and for being here. And we'll see you in the next session in 2 weeks.
See you.
Bye-bye.
Bye.